What's new in Java 23 and why should you care about it? Find out from the best leaders and experts who are closely involved in creating these new Java features and the ones who will help you to use them. In today's episode of JEP Explained, we'll cover JEP 480, which is about structured concurrency, an API for simplifying concurrent programming. It kind of offers you the best of both worlds benefits and simplicity of single threaded code and the performance of multi threaded code. Let's find out how it helps your application. Does it work with all the threads or just the virtual threads? And much more. So get ready to discover what you have been missing all these years. Hi everyone, I'm your host Mala Gupta, JetBrains. And to talk about JEP 480 today, we have with us today José Paumard, Java champion, author, speaker, developer advocate with Oracle, former university professor, jug leader, Jose, oh my god, I'm already tired. Conference organizer, JavaOne Rockstar, presenter of JEP Cafe series on Java's YouTube channel. Jose, a pleasure to have you present with us today and talk about this topic.
Thank you, Mara, for this introduction. It's a pleasure for me to be here, and hello to all the people who are watching us.
The pleasure is all ours. It's always such a pleasure to learn from you, Josie. And we're honored and privileged to have you with us today.
Thank you.
Josie, so my first question is about who is the target audience for this JEP? Who benefits from structured concurrency? Are we talking about all the Java developers here? Or are we talking about authors of, let's say, tools, libraries, or frameworks?
I think that we're talking about both audiences, actually. First, this is still a preview feature. It's a preview API. So you also, when you have this kind of thing, you also need to put this API in the hands of everybody and observe how people are going to use it. But I think that this API can be used and will be used by both the people who are working on the framework development part, because it's going to be useful for them, and also for the people actually writing applications. Now, maybe not every application will be using this kind of technology. I would say that all the people who are writing reactive code as of now, that have the problems of sending many tasks concurrently, with one task doing a first thing, waiting for a result, and then running another processing for that result, and then another request, and then another result, and this kind of thing. You see, when you chain actually your tasks one after the other, all these people are going to benefit from structured concurrency. So that's not every application, but that's, I think, a fair amount of applications around there that can benefit from this feature.
So that means that this JEP should not be missed by the Java developers. Either they would be using it themselves, or they might be using applications or other tools which would be using it. So if they know what goes behind the scenes, it would be easy for them to debug things. So if that makes sense.
Absolutely.
Okay, so now that we know what the target audience is, let's talk about what this JEP is. So I was reading the JEP document and it states that it's an API to simplify concurrent programming. And please correct me if I'm wrong, because I prefer to use a lot of analogies to understand new concepts. So I try to understand it, and this is what I think about it. So now we have a team leader who could lead and influence the action of their team members. Here, when I say team leader, that's the structured concurrency API, and the team members are individual threads, and team is a grouping of threads. So a leader could cancel tasks for all the team members if one of the team members fails, and a leader could abort the mission of the team, so which means canceling all the tasks if they're no longer required. So, Jose, what did I miss?
Well, I don't think you missed many things, actually. That's a very good analogy to understand what structured concurrency is and how you can use it. You give a task to a leader, and this leader will spread the task among the different members of the team. And even if one member of the team actually is also herself or himself a team leader of another team that is under this one, or maybe at the same level, but I mean that is doing subtasks for the main team, then canceling or giving orders to that team leader will also goes go down to the sub team. If there is a cancellation because the result is already there, or if there is a cancellation because an exception or an error has been detected somewhere, then this cancellation will go down to this other team and maybe to other sub teams if there are also sub teams. This is what the structured mean in structured concurrency. So it's really about structuring your tasks in a hierarchical approach, so that you can act at the root level and see your action go down to all the levels of your structured concurrency.
That's interesting. Like an inverted tree, where you could have one leaf or multiple leaves depending on how the node
Yeah,
is placed. So that's
exactly,
interesting. Yeah.
exactly.
Before I ask further about this API, I wanted to know the why part of this API. How does structured concurrency affect the debugging and testing of concurrent applications? Because this is what I read, that this is one of the main reasons of its existence, and kind of one of the big plus points of this API.
Yes, I think so also. Yeah, I would like to go back in time. I'm not that young. And I remember back in the days, there were languages, and some of these languages were using the go-to instruction, right? Maybe some of the people well, listening to us, watching us, remember the languages like the basic, for instance, basic language. You could go to a certain line of your program, and then this program would jump to this line. And somehow the go-to instruction became something that you should absolutely avoid. And all the mainstream languages that we have now uh, do not use this go-to instruction anymore. It's funny to see that in Java, the go-to keyword is actually a reserved keyword, but it's not used. You cannot go to in a Java application. It doesn't make sense. Why doesn't it make sense? Because there are several reasons that were very carefully analyzed by very smart people. But I think that in a nutshell, if you have an application built in a language that uses GoTo, then you're doomed, because when you're looking at a piece of code, a portion of the code of your application, understanding what program, well, what portion of your application can execute this piece of code is actually very hard, because with the go to instruction, you can really jump from anywhere to anywhere, and everybody from anywhere can execute this piece of code. So having a structured language with if then else, for loops, while loops, all this kind of good thing, makes it much easier to understand how your program is working, and makes it much easier to debug it in case something goes wrong somewhere. Because if an exception is thrown on a line of code, you know exactly where your program was just before this line of code was executed. It's usually the line that is just before that, and there is no way you can jump from anywhere in your application to that line of code. So it makes the life of developers and the life of debuggers much easier. Now, it turns out that in Java, we still have hidden go-tos, which is when you create a runnable and you pass this runnable to a thread and execute this runnable in that thread, it's just like issuing a go-to. Okay? When you're on this runnable, you launch it from your main thread, for instance, you just run a small main program, create a runnable, create a thread, not even execute a service, just a regular thread, launch it like that. And if something goes wrong in your runnable, the stack trace will take you to where your thread was created. Okay, it does not take you to where your application created this task and pass that task to a thread. So this is acting like a go-to, and this has very big implications in applications, because we are using this kind of pattern, so not directly with runnables and create thread or pass this runnable directly to a thread. We use executor services, and sometimes we even use something that is completely hidden, which is we pass that to a computable future or to some kind of reactive framework that will actually execute this runnable, this lambda, in another thread for us. But it's still happening. At the core of it, you are passing a task to another thread and you execute it in another thread. And so if something goes wrong in this task, if an exception is thrown, then there is no way you can go back to where this task was created and where this task was actually launched by your application. And so it makes the life of people who are debugging applications super hard, because finding where this task was created and finding where it was launched is really the key element you need to understand if you want to debug your application properly. If you don't have this information, then it's much, much, much harder to debug, to find your bug. And this is what structured concurrency aims to fix. So the first goal of structured concurrency is really to fix this problem, okay? To make it so that when you launch a task, you know exactly where this task was created and where in your application this task was sent to another thread. And the only solution to do that, to fix that, well, the only solution that you have to do that is to create the thread at the same time as the task you create. Because whatever you do, the stack trace, when this other thread is executing this task, the stack trace will take you to where the thread was created. Okay, this is how Java is working, and this is how all the languages are working. So if this point where the thread was created is not at the same place as where you created your task and when you decided to launch it, then this information will not help you debug your application. So if you are in a regular application like Java EE, Jakarta EE, Spring application, this kind of thing, and you launch a task asynchronously, which is what people do most of the time, your task is going to be executed in an executor service. This executor service carries platform threads. So platform threads are different than virtual threads, okay? And this executor service, because the platform threads are very expensive to create, this executor service is created at the same time as your application. So basically, you launch your application, you launch the executor services that you need, if you have more than one, okay? And when your application is running, after like 2 days, 3 days, 2 months, okay, you launch your tasks. These tasks are executed in these platform threads that were created 2 months ago, all right? And if one of these tasks crashes, then the stack trace takes you 2 months earlier when you created the thread that is executing it, all right? This is what is happening at the moment. Now, with structured concurrency, you create, it's just like the image of creating an executor service on demand when you want to launch a task asynchronously is the right one. The only difference is that instead of creating platform threads, because you can't do that because it's too expensive and takes too much time, you create virtual threads. And as we know, virtual threads are lightweight threads that take just nanoseconds or microseconds to create and don't consume much memory. So you can really create them on demand. And because you have these tools, if you want to launch a task asynchronously, now you just create this structured task scope object, which is the basic object of structured concurrency. You pass your task in this stuff, and if something crashes in it, it will create a stack trace within the virtual thread, and the stack trace of the virtual thread will take you where your structured task scope object has been created, which is actually where your task was created and launched asynchronously. So it solves the problem of debuggability because now you have a stack trace that actually takes you in your application where you launched your task asynchronously, which is, I think, one of the key points of structured concurrency. And what you need to understand is that you can't create executor services on demand because they are based on platform threads. Well, if you have an executor service that creates a virtual thread, you can, but most of the executor services that you have and that applications are using nowadays, these are executor service. These executor services are creating platform threads. So you can't do that with executor service and platform threads. So you need actually virtual threads to be able to enable the use of structured concurrency, right? Because concurrency is about creating threads on demand. And for that, you need a model of threads that is lightweight, and this is what virtual threads are giving you. And once you're done with the execution of your task, once you're done, you let your executor service die. All right. You don't think about reusing it. Structured task scope objects are not reusable objects. There is no point in trying to reuse them. These are totally expendable objects. Once you're done with the task you want to execute, you just close them, you kill them. Maybe this is where the analogy with the team you were talking a few minutes ago ends, because you don't want to kill your team, of course.
No, that would not be a good thing.
There are good people in it, so you want to.
Yeah.
But
What
virtual thread, I mean, the virtual thread die when you don't need them anymore. So at the end of it, your structured task scope object is empty, and you just close it, and everything is done.
No. What you talked about debugging the applications and the ease of doing that with structured concurrency, that's very powerful, because as we know, we write code once, but that's read and used so much more than writing just code once. So that's really powerful. And I think what we talked about initially, that this makes sense for almost all Java developers. So every Java developer who's watching this, they should make it a point to know more about it and to use it in their application. I know it's still a preview feature, but they
Yeah.
should kind of get a hang of it and start using more of it. And you also mentioned that this is not to be used by the regular threads, only with the virtual threads. Uh,
Yeah.
did I get that right?
Yes, absolutely. Because it is about launching the thread that is going to execute your asynchronous task at the same time as you submit this task to this thread. Okay. When you do that with executor services, you pass your task, your runnable or your supplier or whatnot, to a thread that has been created maybe a long time ago. But when you do that with structured concurrency, you create that thread on demand. You create that executor service that is not an executor service, that is called a structured task scope on demand, so that everything is created at the same time and in the same place in your application. Yeah. So without virtual threads, it wouldn't make sense to use. You could, from a pure technical point of view, you could have it with platform threads, but the performance would be so terrible that nobody would use it. So you definitely need a virtual thread programming model to use this kind of approach. Yeah.
So, that makes sense. And you already talked about the unstructured way of working with things using executive service. So do you have some examples, like let's say one or two, to highlight how structured concurrency simplifies managing multiple concurrent tasks for us?
So the idea. You want me to show some code, right? You would like to see some code in action, structured task
Yes,
code. Okay, so
yes, yes.
let me bring my IDE. Okay, so suppose we have a record called weather. It just wraps a string weather, and we're going to create this scope object, which is of type structured task scope of weather, like that. And this is actually the executor service, which is not an executor service, that is given you by the structured concurrency API. This is the core object of the structured concurrency API. Now, this object is auto-closable, and I can ask my IDE to surround it with a try with resource block, and this is exactly what I want to do. And you see, suppose that this piece of code is actually in the middle of a very complex application. When I exit this try with resource block, this scope object will be closed. The scope.close method will automatically be called for me. And it means that everything that happened in this object is going to be done. And this object will be garbaged after I leave this method, right? Once I'm in this object, what I can do is pass asynchronous tasks to this object. And for that, I have a method that is called fork. And this fork method will take a callable as an argument. So let me create a callable. Callable is just a lambda. And I'm going to create a new weather, for instance, sunny, something like that. So this way of creating this weather is not very interesting because it doesn't block, it doesn't do anything. Okay, so I'm going to, for instance, put this between curly braces and add thread.sleep for, let's say, 100 milliseconds. Okay. And by the way, maybe I could put that in a method. Callable get weather. Oops. Sorry. Okay, I'm going to call that read weather, something like that. So it's going to wait for a certain amount of time, 100 milliseconds, and return sunny after that. So 100 milliseconds is roughly the time it takes to request to query a REST server. So that's probably what it means. And I'm going to call it read weather A, for instance. Okay, and I'm going to do this 3 times, B and C, and I'm going to duplicate this to create method B. And the method B will tell me that the weather is rainy with only one N. And read weather C will tell me that it's cloudy. All right. And what this is doing really is that it is going to take this task, this callable here, that's a callable, right? And it's going to execute this callable in a virtuous thread that is created on demand by this scope object. So if I call fork 3 times, it's going to create 3 virtuous threads, and each virtuous thread will execute read weather A, B, and C. So these tasks are going to be executed concurrently within this structured task scope object. Every fork returns I'm going to call it future, but it's not a future. And I'm going to call it future A, future B, future C. The real type is a subtask, actually. You see, a subtask of weather, which is a member class of a structured task scope, and it acts some kind as a future. So it's almost like a future. It used to be a future in previous preview versions of the API, and now it has been changed for some reason. So what I get in exchange is some kind of future. So you see that the pattern is actually very similar to the executor service pattern. You create your pool of threads. Here it's a structured task scope, and it's a pool of virtuous thread. It does not pull anything. It creates virtuous threads on demand every time you create a task and you pass this task to be executed in the scope object. And in exchange, it gives you an object that actually will give you the result of the execution of this task when it's done. To be sure that all this is done, you need to call scope.join, and this is going to throw an exception. So let me catch it. It's an interrupted exception, and once this join method returns, it means that all the tasks that have been submitted to this scope object are done. Done means that they either produced a result or produced an exception. It's one of them. So now what you can do is say, okay, future A dot state. And you know what? I'm just going to print this. Sorry. State A. Remove this. State A, B, and C. So that's going to be B, and that's going to be C, B, and C. And say, for instance, that actually the state B is going to throw a new illegal state exception, illegal state, instead of producing a result. So this is going to disappear. And I can already run this code. Okay, I'm just going to print done here to make sure that everything has been properly executed. And if I run this, you see that A is a success, B failed because B is bound to throw an exception, and C is also a success. And now, depending on the state that I have here, I can say that, for instance, if future.a.state is equal to state. So state is state is actually an enumeration that has been added in a structured concurrency. You see that this is actually one of the difference between this subtask object, future A, future B, future C, and the real future object. By the way, I should really call them. You know what? I'm going to do that because it doesn't make a lot of sense to call them future. They are some kind of future-like object, but I'm going to call them subtask because this is what they are.
That makes much more sense. Yes.
Yeah, it does.
Yeah.
It's good if you already know what a future is. It's good to have this future model in your mind because it's actually the same object, right? But it's not the same API. So yeah, from a concept point of view, it's just like a future. So if the task is in success, then you can call subtask.a. I'm going to print the result. Subtask.a and called get on it. And get is just the weather. So if I run this again, you would see that it just returned me subtasks, just returned me the weather that it returned. So that's I would say that's the core pattern. If you understood that, you understood 90% of structured concurrency, really. There is still a 10%, all right? But,
yes.
but I mean, it's really as simple as that.
So I have a quick
the pattern
question.
is super simple. Yeah, sure.
For read whether B method, you threw an exception instead of making it complete the way it should be.
Yeah.
But even then, the method C executes. So when we talked about structured concurrency in the first place, we talked about that a leader could cancel all the tasks depending if one of the tasks fails. So do we have to initiate that explicitly, or does that happen implicitly?
No, you don't have to initiate that explicitly because the API can do that for you. Actually, there are three structured task scope objects. The first one is this one. I'm going to put it here. And there's another one called shutdown on success. I'm going to use shutdown on success. Okay, shutdown on success. If you're querying a weather forecast or several weather forecast servers, odds are that if you ask the weather forecast for a given place in the world and for a given date, all these servers should give you the same answer, right? If they don't, maybe there's a problem somewhere. So what you really want actually is the first answer. And once you have it, you're not interested in all the others anymore. And this is what the shutdown and success is doing, okay? And I'm going to get rid of these subtasks here, because I'm not going to need them. I'm going to comment that, and that also. So now I have a scope object that takes a bunch of tasks, and that returns, this join method does not return when all the subtasks, all the tasks read weather, are complete, but when the first one produced a result. So suppose that A, and I'm going to tweak this example a little. So A answers super fast in 10 milliseconds, but throws an illegal state exception. Okay. B answers a little slower, 50 milliseconds, but it produces a result. And C also, but in 100 milliseconds. You will see that actually the API is smart enough to detect that a task produced an exception, and then it will wait for the next one to see if it produces an exception or a result. and it will give you the first result that is produced by all your tasks. All right. And this join method will return, and if you call scope dot result, it's a weather var result. Okay, and it throws an exception, which is an execution exception. Okay, and now I can print this result, run the result, and it should be the weather from B that is going to be returned. So it's rainy. Is that from B? Yeah, it's rainy. And you see that if I say, oh, but actually B also throws an exception, then C is going to provide an answer. Okay, so now it's cloudy. So this is how this other structured task scope is working. It is still a structured task scope. It's still the same pattern, but it has a semantic that is slightly different. And I'm going to put it here. Shutdown success. So this one returns, gives you the first result that your task have produced. And it's smart enough to discard the task that produced an exception. And there's yet another one, which is the shutdown on failure, this one. Okay, so now the semantic is different. What you're saying is that to be able to produce a result, you need all your tasks to produce a correct result. And if one, so this does not produce a result anymore. Okay, the join method will wait for all the tasks to produce a result. All right, I'm going to get rid of this one. I don't need you anymore. Okay, so now I'm going to comment this. Okay, I need to have these var subtask A here. That's going to be B and C. B and C. And now I need to analyze these once again, just as I did, right? I'm not going to write all the code. That's going to be tedious. And this shutdown on failure will tell me, okay, you're done because everything was in success. But if one of these tasks, you see, so if the first one throws an exception, then it will stop there and cancel all the other tasks. You see, this one is going to throw an exception after 10 milliseconds, and the others, 50 and 100 milliseconds, they should be canceled. So if I run the code, you see that A is failing. Let me show that again. And shutdown on failure actually canceled B and C, so the results are unavailable. Okay, because it knows the semantic of this task scope is that if one task fails, then you cannot produce a result. So there's no point in waiting for all the other results, and all the other results are going to be cancelled. We can see that if A produces a result, okay, so I have a first result that is not enough for the global result, and the second one produces the exception. Now A will be success, B will be failed, and C will be unavailable because it will be cancelled by the API. So hopefully this is what is going to happen. You see, A is okay because A was very quick to provide an answer. Then B failed. So the shutdown on failure realized that and said, okay, I don't need C anymore because I cannot produce a result. Okay, so we have actually 3 structured task scope objects with 3 different semantics. And by the way, if you want to implement your own semantic with another semantics, suppose that you are launching really many tasks, and you want 80% of them to be in success, and 20% of them can be failing or unavailable or whatnot. Then you can extend this class here and implement this kind of behavior. It's a little tricky. That's the 2% of the, of the API we're talking about. All right. So that's not for everybody, but it's something that you can do. So it's very interesting.
Yes, so Jose, the examples were amazing, and the way you demonstrated all of these and added that you anyone could extend it and create their own rules. I think that's super interesting. Super interesting for the examples that you mentioned about where anyone could have, let's say, 80% of success or 20%, and that would, I think, that would help in a lot of use cases. So super
Yeah.
interesting.
Thank you.
I love that. Okay, so the
Okay.
other
Done with the idea.
yeah, done with the ID, the amazing ID. Well, what was the name you said? Okay.
The name of the IDE, you mean?
Yes, yes. No, no,
Oh,
it's okay.
it's an IDE made by the company called JetBrains. Maybe you've heard of it before. It's a great
Ah,
company. It's a great product. I can only tell you that.
I agree. I agree.
I've been using it for years. I can't even remember when I started using it. That was a long
Me
time ago.
too. Me too. I love the ID and the features, and you demonstrated that quite well. Thank you so much.
Thank you.
So, the next question I wanted to ask to you is, should all the developers be looking at, because you mentioned about, we just saw the amazing benefits of this new structured concurrency API. Should developers be looking at replacing all instances of, let's say, their unstructured concurrency, which they've been using executor service, with this style of programming? Should they be doing that?
That's
Yes.
actually yeah, that's actually an excellent question, and I think a tough question. Uh, and I would like to give an answer that is a very pragmatic one. Are people going to move all their code, reactive code, to structured concurrency all at once on day one when this API makes it as a final feature in a JDK? I don't think so. The reason is not because the API is not good or it's better or worse or whatnot. It's just because developer teams just don't have time for that. All right. When you're working in a team and you handle an application, you can only act on a certain amount of lines of code every week or every month, and there's no way you can rewrite your application using this kind of pattern. I remember when Java 8 was introduced, Lambda Lambdas made it to the JDK, the Stream API made it to the JDK, and the question was, are we going to rewrite all our code with Lambda expressions? And the answer clearly was no, because we don't have the time for that. But after 10 years, when you take a look at all the code that has been produced, all the Java code that has been produced in the past 10 years, you can see that you have lambdas and streams and new collections all over the place. People are using it absolutely everywhere they can. So I suspect that it will be the same for structured concurrency. Maybe not at the same pace, because it's not as easy to embrace as Lambda expressions on the Stream API. It's probably a little harder, but I suspect that in 5 years, 10 years from now, it will become completely mainstream, and people will not even think about it. The programming model, both the debug ability, we talked about that earlier, and the new programming model, compared to what you can do with reactive programming, is so much simpler, given that the performance you may expect are the same. That, I mean, at some point in the future, they probably won't have any. You won't have any interest in using complex, super complex reactive approach, as it is the case now. Reactive programming is really great now because it's working on the platform thread model, which is a very heavy stuff, and it really uh, leverage leverages the computing power given by this thread in an amazing way, right? But now we have this new virtual thread model, which is being improved version after version. At some point, the several caveats that they are using virtual threads will be fixed very soon, or sooner or later. And all this will be gone, and they will, I mean, comparing the programming models and the performance you have will make it so that I suspect that in the future, people are going to be using this kind of approach rather than the classical callback based reactive programming.
That makes sense.
That,
As they
that will be,
discover,
yeah.
Yes, as they discovered more benefits and the features of the new programming model, they would be using and writing newer code, which would be using these features rather than going back and changing the previous code. That really depends. If they have a lot of problems with the previous code, then yes, the team might invest some efforts in doing that. But yes, as you rightly said, not all developers, not that teams would not have those kind of resources to spare in rewriting code.
Yeah.
And why to touch the code which is working okay? So I think that's that makes sense as
You
well.
don't fix something that is working, right? You all
Yes,
agree on
yes.
that.
Right. And unless it's really hurting, even the working code is hurting, then you do something about it. Otherwise, we
Exactly.
let it be. So, this is probably the last question that I want to ask about. I know that you talked about debugging, and I also want to talk about the observability. I know that includes debugging, but when I mention observability, I think I'm talking about capturing more data points. So, how does structured concurrency help with the observability of applications?
Actually, it's the same kind of problem that the problem you have with debugability. When you try to profile an application that is running on some reactive framework, because all the stack traces that you have with the task that you launched are actually stack tracer that takes you all through your reactive framework to where the threads were created, that is when your application was created. What you're really profiling is not your application, it's really the framework you're using. So it's very hard to know if your application is working efficiently, because the efficiency, the performance of your application really relies on the performance of the reactive frameworks, the reactive framework that you are using, which is fine. I mean, there are reactive frameworks that have been developed for years, for more than 10 years now, that are really working really great. And I mean, you rely on them and you trust them, and I think you should. It's just working. But at some point, the the correctness of your application also relies on the fact that uh, writing blocking code is a bug. All right, in this kind of approach, if you have a reactive framework, so basically all your business processes, all your processes are split into small elementary tasks, and each task should be non-blocking. And if by mistake you write a task that is actually blocking, then it's a bug, and then it can have an impact on all your application. So you need to fix that bug, you need to detect it, to fix it, to publish your fix, right? When you're using the virtual thread approach, you write blocking code happily. What I mean by happily is that there's no problem in writing blocking code. Actually, you should write blocking code. There's no point in writing reactive code on top of virtual threads. And the fact that the platform thread is not blocked is not your responsibility as a developer, but the responsibility of the API, of the virtual thread API that you're using. All right. You write blocking code, the API detects that you're blocking, and then all this mechanism implemented by virtual thread with the moving, the backing up of the stack trace of this virtual thread to the heap memory is triggered with the continuation and everything. Right? This is triggered, but this is triggered by the API. It's not your responsibility. So it really makes your life as a developer much easier, because writing blocking code is not a bug anymore. You don't need to take care about that. This is taken care of by the API. The fact that your platform threads are not blocked by your code is the responsibility of the API you're using. And if the API is the JDK, many people are watching that very carefully. So there may be bugs in it, but not that many, I guess, especially in that space. So at least it's not your responsibility, it's the responsibility of the people who are writing the APIs, which is, I think, much more comfortable for developers.
Right. So in the next parent teachers meeting, I can go and tell my kids teacher that I do write blocking code without feeling ashamed. I'll tell I'll tell them I'm using
Sure.
virtual threads. So
I
I can do
just
that
wrote
now.
thread.sleep, which is basically a blocking code in the example we
Uh,
just we just
right.
we
Right.
just saw.
Right, so observability with the structured concurrency does give a lot of data points which can help developers understand how their applications are performing. And if they can detect that part, there are ways to make them more performant. So that's great. So debugging is being taken care of. Uh, Enhancing the performance. The API with the virtual threads does it much better, and uh, added benefits of using other tools, which helps with observing the application. So I think it's a lot of benefits that are being offered to developers. I think that's great, and kudos to the Java team, which is doing all the innovation. So thanks to
Yeah,
you.
there's a great amount of work. And by the way, it's still a preview feature, so if you
Mhm,
want to try it, by all means do so. If you want
mhm,
to play with it, and by all means do so. And if you have
mhm,
feedback, comments, and everything, please provide them, because the reason why it is still in preview is just to gather more feedback from the community and from the people who are going to
mhm,
use it. So if you have anything, any idea, you need to connect to jdkjava.net/loom. There are mailing lists there.
mhm, mhm,
Publish your comments, your questions, your point of view, your requirements, and
mhm.
it will help improve the API before it makes it final in the JDK.
Yes, because I think this time it's being previewed without any changes just to get more
Yeah,
feedback on the future. Yes,
exactly,
yes. So
exactly.
it makes sense for developers to send in their comments before it's made permanent, because then if they talk about it, won't make a lot of difference. Now is the time to
Yeah,
try it out. And this is one of the reasons why we are doing this JEP Explain series, so that people are more aware about the features and they get to try them out. Because a lot of times, some of the features do not get the spotlight and others do. So, uh, uh, an initiative to kind of have spotlight on all the features so that they could be used by developers.
thank you.
And on that note, we are moving to our fun section, which is about. So the first one is the tongue twister section. So, Jose, I would display a tongue twister on the screen, and you're supposed to say that not very slowly, that has to be quick. And you're not supposed to say it correctly because, oh my God, all, I cannot see you doing that right in the first place. So, your time starts now. No, no, of course, you can do that.
Jumbling Java's JDK APIs jostle jubilantly as structured concurrency consistently collides with capricious cryptographic thread tricks.
Why?
I'm not sure what
Oh,
it means, to be honest.
that's okay.
But
You're not
yeah.
supposed to know, but you did that excellently. So,
Oh, thank
um,
you.
full points to you on in that section. So the next section is about. I'll display a set of statements to you for you, three in total,
Okay.
and for each statement that I would display, you'll have to react to that statement as
Okay.
if you are using an emoji to do that. The only difference is you cannot type out that emoji. You have to enact that emoji. So you have
Oh,
to
okay.
react to a statement in the form of an emoji, which has to be enacted and not typed out. And the first statement is Java 23 is about to be released. Oh, I like that.
That's a double emoji. That's
Yeah,
I should put it. Yeah.
that's
My daughter is
that's
so much better than me to do that.
I love that. You're the first speaker who did that for
Oh,
Java 23. Yes. So the next one is unconferences are more fun than regular conferences.
more
And
fun, more fun. It's not very nice for people who are working very hard at making regular conferences fun. I just would like to
Mhm,
say that I love conferences. There are several conferences I go quite regularly. The next one will be in Mexico, by the way, in 2 weeks, called
mhm,
Jalapeno. It's organized by folks over in Mexico. Kudos to
mhm,
Andres and Ixchel for doing that. And
mhm,
yeah, unconferences are really about conversation and interaction between people and everything. And these are
mhm,
absolutely great events. If there are unconferences close to you, I'm talking to
mhm.
the our audience, and you want to try that, by all means do that. You'll be amazed. Yeah. Absolutely.
And I think you also disorganized one of the unconferences.
Yes, we are doing J Chateau with the Paris Java user group.
Mhm.
Next edition will be in March 2025, and it takes
Okay.
place near Paris in France. And you can connect to jchateau.org if you want. And I
Mhm.
also participate in J Alba in Edinburgh,
Mhm.
and I think that this year it will be in May or April, maybe. I think it's
Mhm.
end of May,
Okay.
2025, and it takes place in Edinburgh. My friend Maurice Naftaling is disorganizing J Alba.
All the best to you for that.
Jalba.scott.
Yeah. So the last statement is you do not enjoy cooking.
Yes, I do. I live in
I
France, and in France we like cooking usually. And I am
mm,
yes, cooking is about there are two good things in cooking, and
mm,
I think you'll agree with me, Mala.
mm,
First is the pleasure of having good sense in your house for a few hours, or few minutes. And second, it's about gathering people you love around a table and sharing
mm.
what you just cooked. These are the two most important
Abs-
pleasure in cooking.
Absolutely. I do not. I agree with them absolutely, because we do the same in India as well. So when we have festivals, so a lot of cooking happens at home, and then we have friends and family come over, and that's the best part, to have them all over at your place and enjoy the food together. So, and I love cooking too. So I
Absolutely.
agree.
There you go.
So, on that note, we are towards the end of the interview. Thank you so much, Jose. It was such a pleasure. It's
Thank you,
always a
Mala.
pleasure to talk with you and to learn from you. Thank you so much for sharing your time and your expertise. And I hope everyone's watching, they would try out this JEP and conquer this API so that they can make their applications much better. If you have any closing
Thank you so
remarks.
much, Mala. Thank you for having me.
Okay, so until we host you next time, bye bye.
Bye bye.